So there are some concluding points to remember about matter waves. Matter wave basically is the wave which represents any piece of matter or any object, meaning the equation we use to describe the wave nature of an object. So matter waves exist only when the particle is in motion. Yeah, so obviously, you can call something a wave only when it's moving, right? So even if you take light or even the waves at the ocean, if it's a calm water body, you don't call it wave. Only when there's some moving water you call it a wave, and that applies here as well. So a wave exists only when the particle is in motion. All particles, charged and uncharged, have a wave associated with them. Heavier the particle, smaller the wavelength. Group velocity is the velocity of the particle. Phase velocity can be larger than the speed of light. So I think the first 4 points are self-explanatory. This point we'll come to it. Wave and particle nature are complementary, and only one of them is found to dominate, which is what I explained in this slide. So depending upon your size, only one of the natures is observed at any time. The wave nature gives rise to uncertainty in the simultaneous measurement, meaning if you are describing an object as a wave, then you cannot be sure of both its position and momentum at once, or its energy and time at once. You know one quantity precisely, then there is always an uncertainty in the other. That is what this point says. And now coming to this point, phase velocity is larger than the speed of light. This is something where a lot of people have a question. How is it possible? Even I remember asking Prita ma'am the same question when she taught this in our class. So we've always grown up learning that light is the fastest thing, right? So how is it possible that something is larger than the speed of light? It's possible because phase velocity does not exactly represent the speed at which that wave moves. It represents the rate at which the phase of that wave changes. And hence it can be greater than the speed of light. So that is one way of understanding. Or if that doesn't make sense to you, speaking mathematically, phase velocity is c squared by v, where v is group velocity. And group velocity can be a decimal number, right? Let's say it is 0.1 or something. Then your phase velocity is going to be c squared divided by 0.1, which is 10 c squared, which is much greater than c, right? So mathematically speaking, also phase velocity can be greater than the speed of light. And logically the explanation is, it is the rate at which the phase changes. Phase of each individual wave changes. It's not the physical speed at which the wave moves. So it makes sense for this one to be faster than the speed of light. But this one is a proper physical velocity, like displacement by time. So this has to be slower than c.